Okay, Assalamu alaikum students. I hope all of you are doing well. So let's start with IGCSE Physics, October November 2023, paper 4, variant 3, 1 hour 15 minutes paper. So let's zoom in a bit here. Yeah. Oil of density zero point 0.8 grams per cm cube is poured gently onto the surface of water of density 1 gram per cm cube. The oil and water do not mix. Describe and explain the final position of the oil relative to the water. हमने बताना है what is the final position of the oil relative to water. How will you tell that? First of all, can you realize oil has a lesser density? Oil की density less है, water की density more है. What will happen? Oil will float on the surface of water. ऑयल क्या करेगी सरफेस ऑफ वाटर पे फ्लो फ्लोट करेगी सो यू विल से सिंस ऑयल हैज अ लेसर डेंसिटी देन वाटर ऑयल floats on the surface of water. So you will say oil stays on the surface of water. Stays on the surface of water. And what is the explanation for this? Beta, iski explanation kya hai? What will be your explanation for this? Since oil has a lower density than water. Since oil has a lower density than water. Simple. Let's further move ahead. An irregularly shaped solid has a density of this. ठीक है आपको irregularly shaped solid की density given है. Irregularly shaped solid has a density of this. Describe a method to measure the volume of the irregularly shaped solid object. How will we measure the volume of the irregularly shaped solid object? How will we do that? You will say pour, or you will say take a measuring cylinder with some amount of water in it. Yeah, measure the initial volume of liquid in a measuring cylinder. Pour some water in the measuring cylinder and measure the initial volume of water and measure this initial volume of water in the measuring cylinder. उसके बाद आप क्या कहोगे? What will you say further? Immerse the irregular object. Immerse the irregular object, irregular solid inside the cylinder. Measure the final volume. Measure the final volume. And lastly, the difference between final and initial volume. Beta, final and initial volume के बीच का difference is the volume of the irregularly shaped object. The difference between final and initial volume is the volume of the irregularly shaped object. Is the volume of the irregularly shaped solid. Simple. The volume of the object is this. Okay, now you have the volume of the object. You have to calculate the mass of the object. How will you do that? Yes, any ideas geniuses. Density is equals to mass over volume. Beta density है आपके पास. Yes, 2.7 gram per centimeter cube. You want to calculate the mass. Volume क्या है? 83. 2.7 into 83 is your mass. What does your mass comes out to be? बेटा मास क्या आ गया आपका? यस जीनियस इज इन द चैट. Mass comes out to be 2 to 4.1 grams. If you round it off till two significant figures, this will become what? 220 grams is your mass of the object. आगे बढ़ते हैं बेटा. Now, let's see question number 2. Figure 2.1 is a graph that shows how the extension of a spring varies with the load applied from it. Determine the spring constant K. You have to calculate the spring constant K. How will you do that? हाँ जी, spring constant कैसे निकालेंगे? K is equals to force over extension. What is your force? 14. Extension क्या है? 4 centimeter. Divide कर दो. 14 divided by 4. What does your K comes out to be? K is equals to 3.5 Newton per centimeter. Simple. According to two significant figures भी हमने निकाल दिया. Okay. On figure 2.1, mark the limit of proportionality and label this L. Limit of proportionality is the point up till where the force versus extension graph is linear. The force versus extension graph is linear up till this point L. This is your limit of proportionality. Let's further move ahead. Figure 2.2 shows a car traveling at constant speed around corner A on a road. Okay. On figure 2.2, mark with an arrow the direction of the resultant force acting on the car as it travels around corner A. Beta, what will be a resultant force acting on the car? Resultant force acting on the car whenever you are moving in a circle is towards the center. बेटा जब भी आप सर्कल में मूव कर रहे होते हो योर रिजल्टेंट फोर्स एक्ट्स टूवर्ड्स द सेंटर ऑफ द सर्कल. ठीक है, जब भी आप सर्कल में मूव कर रहे होते हो योर रिजल्टेंट फोर्स एक्ट्स टूवर्ड्स द सेंटर ऑफ द सर्कल. सिंपल. कॉर्नर बी हैज अ स्मॉलर रेडियस देन कॉर्नर ए. ओके, कॉर्नर बी का रेडियस क्या है? स्मॉलर है कंपेयर टू कॉर्नर ए. परफेक्ट. The car travels at the same speed around corner B as around corner A. State how resultant force changes due to the car traveling around a corner of a smaller radius. You will say as R decreases, resultant force, or you can say centripetal force increases. Now write down some key points. यहाँ पे छोटे से कुछ key points लिख लो. Centripetal force is affected by three factors. Centripetal force कितने factor से affect होती है? Three factors से affect होती है. The first being the mass of the object. If the mass increases, centripetal force increases. If your mass decreases, your centripetal force decreases. सर दूसरा कौन सा फैक्टर होता है जिससे सेंट्रीपिटल फोर्स इफेक्ट होती है? वेलोसिटी. The second factor which affects centripetal force is velocity. If your velocity increases, centripetal force increases. If your velocity decreases, centripetal force decreases. The third factor which affects centripetal force is radius. If your radius increases, centripetal force will decrease. If your radius decrease, centripetal force will increase. This is a inverse relationship. Mass और velocity के साथ direct relationship है. So here, can you realize corner B has a smaller radius? Your R decreases, that's why centripetal force increases. Simple. Let's further move ahead. Now let's see this. Figure 3.1 shows a boy throwing a ball at an object in a fairground. The ball has a mass of 190 grams and travels horizontally with a constant speed of this. Calculate the momentum of the ball. How will you calculate the momentum of the ball? Momentum is equals to mass into velocity. What is your mass? 190 grams. Convert it into kilograms divided by 1000. Multiplied by the velocity, that is 6.9. Can you calculate the momentum? Genius is 190 divided by 1000 into 6.9. Your momentum comes out to be what? 1.3 Newton second is your momentum. Perfect. Let's further move ahead. After hitting the object, the ball bounces back along the same straight path with a speed of 1.5 meters per second. The object has a mass of this. Okay. Calculate the speed of the object after it is hit by the wall. Okay, हमने speed of the object निकालनी है after it is hit by the wall. How will you do that? Do you remember? Do you remember the law of conservation of momentum? Do you remember the law of conservation of momentum? Yes or no? Sir, law of conservation of momentum क्या कहा करता था? Law of conservation of momentum used to state that the total momentum before collision is equals to the total momentum after collision. Do you have the before collision diagram? Yes. Before collision की diagram ये बनेगी. Before collision, the object is stationary at a velocity of 0. This ball of mass 190 grams is traveling towards the right with a speed of 6.9 meters per second. This is your scenario before collision. Let's also assume that the vectors towards the right are considered to be positive, the vectors towards the left are considered to be negative. What will be your scenario after collision? Beta, after collision आपका क्या scenario होगा? Can you realize after collision, the ball travels with a speed of 1.5 meters per second back along its straight path. So after collision ये हो रहा है कि आपकी ball travel कर रही है with a speed of 1.5 meters per second like this. You have to calculate the speed of this object. How will we do this? Just focus on the board. Before collision, can you realize the only momentum is due to the ball? बेटा बिफोर कोलिजन आपका मोमेंटम सिर्फ और सिर्फ बॉल की वजह से होगा बिकॉज ऑब्जेक्ट स्टेशनरी है उसका मोमेंटम जीरो होगा सो व्हाट विल बी योर टोटल मोमेंटम बिफोर कोलिजन 1.3 व्हाट विल बी योर टोटल मोमेंटम आफ्टर कोलिजन बेटा टोटल मोमेंटम आफ्टर कोलिजन किस तरह निकालेंगे you have a ball of 190 grams traveling towards the left with a velocity of 1.5. How will you write this? Mass of 190 divided by 1000. Can you realize the velocity is towards the left? लेफ्ट साइड वाले वेक्टर्स को हमने नेगेटिव ले लिया दिस विल बिकम व्हाट नेगेटिव 1.5 प्लस what is the momentum of the object? The object has a mass of 1.8 kg. Object का mass क्या है बेटा 1.8 kg. It is traveling towards the right with a speed of v. So plus 1.8 v. Can you calculate the answer of v? Yes, easy. First of all, this becomes okay 1.3 is equals to negative 0.285 plus 1.8 v. Take it to the other side. This comes out to be 1.585 is equals to 1.8 v. 1.585 divided by 1.8 is equals to your velocity. Can you calculate this answer? The answer comes out to be 0.88 meters per second is your speed. Simple as that, nothing complicated here. Easy. Let's further move ahead. Let's move forward. Now, the kinetic energy of the ball before collision is this, and after collision, the kinetic energy is this. Calculate the change in total kinetic energy of the ball and the object during the collision. How will you calculate the change in kinetic energy? The change in kinetic energy is equals to what? Total kinetic energy before collision minus total kinetic energy after collision. Beta, can you realize the total kinetic energy before collision will only be equal to the kinetic energy of the ball? बेटा बिफोर कोलिजन आपकी टोटल काइनेटिक एनर्जी विल ओनली बी इक्वल टू द काइनेटिक एनर्जी ऑफ द बॉल. व्हाई? Because before collision, the object has a velocity of zero. That means before collision, the kinetic energy of the object is zero. After collision, the kinetic energy of the ball is given zero point 0.2. Can you calculate the kinetic energy of the object after collision? Yes. The object has a mass of 1.8. The velocity was 0.88. So 1 upon 2 into 1.8 into 0.88 cow square. This was the kinetic energy of the object. Let's calculate it. zero point 0.5 into 1.8 into 0.88 cow square. Okay. So 4.5 minus 0.2 plus 0.697. Can you calculate the change in kinetic energy? 4.5 minus zero point 0.2 minus 0.697. This comes out to be 3.6 joules. Corrected till two significant figures is your change in kinetic energy. Simple. Let's further move ahead. आगे बढ़ते हैं बेटा. The lowest possible temperature is 0 Kelvin. State the name of this lowest possible temperature. Absolute 0. Nitrogen boils at 77 Kelvin. Calculate the boiling point of nitrogen on the Celsius scale. How will you calculate that? Celsius scale में आप nitrogen का boiling point कैसे निकालोगे बेटा? How will you do that? You will say Kelvin is equals to degree centigrade plus 273. Kelvin क्या था? 77. Degree centigrade plus 273. Can you bring this 273 towards the left side? Yes. 77 minus 273 is equals to degree centigrade. Can you calculate this answer? 77 minus 273. This degree centigrade comes out to be minus 196 degree centigrade. Simple as that. Nothing complicated here. आगे बढ़ते हैं बेटा. The temperature of a fixed mass of gas at constant volume changes from 300 kelvins to 400 kelvins. So आपका टेम्परेचर क्या कर रहा है? Your temperature is increasing. State and explain in terms of particles the effect on the pressure of the gas. The pressure increases. Now, what will be the explanation? I have written this explanation multiple times in this past paper series. What will you say? As temperature of gas increases, the kinetic energy of gas particles increase. Kinetic energy of gas particles increase. As the kinetic energy of gas particles increase, क्या होगा? हाँ जी, as the kinetic energy of gas particles increase, क्या होगा? There will be more frequent collisions. This results in more frequent collisions. More frequent collisions causing the force per unit area to increase. Per unit area to increase, and hence the pressure increases. Simple as that, nothing complicated here. A sample of a gas is at a pressure of 120 kilopascals. The volume of the gas is doubled at constant temperature. Which law are we following? Boyle's law. जब भी आपका टेम्परेचर कांस्टेंट होगा and you have to see a relationship between pressure and volume, you will apply Boyle's law. Now your volume is getting doubled. Volume V से 2V हो रहा है. Pressure क्या हो जाएगा बेटा? Half. It will become what? 120 divided by 2. That is equals to 60 kilopascals. Simple. Figure 5.1 is a scale diagram of wavefronts of red light approaching a gap in a barrier. Okay, so this is diffraction happening. I can see it from the diagram. On figure 5.1, draw three wavefronts after the wave has passed through the gap. What will happen? Diffraction will happen. So your waves will start to curl like this. Your waves will start to curl like this. Also, one more thing that you must notice at all cost. एक चीज क्या notice करनी है बेटा कि आपकी wavelength before diffraction. Wavelength before diffraction is equals to what? Wavelength after diffraction. I am drawing it digitally. So you might feel कि wavelength before and after same नहीं है, but when you draw it with a pencil, you must make sure that the wavelength before is equals to the wavelength after diffraction. Let's further move ahead. Figure 5.2 shows the same barrier and gap. A wave of blue light approaches this barrier. Okay. What do you remember from electromagnetic spectrum? Blue light की wavelength is less than the wavelength of red light. Okay, let's see. Draw three wavefronts of this wave before it reaches the barrier. अब जो आप wavefronts बनाओगे उनकी wavelength will be less than that of red light. Somewhat like this. Let's draw the wavefronts carefully and make sure that the wavelength or the gap between the wavefronts is less for the blue light क्योंकि blue light की wavelength क्या होती है बेटा कम. Also, let's read the second part. You will see another magic. Draw three wavefronts after the wave passes through the gap. Since the wavelength of blue light is less, क्या होगा? Amount of diffraction will also become less. How will you draw? बेटा आपने लेस कर्वेचर दिखाना है, आपने कर्वेचर कम कर देना. After diffraction, you have to make sure that your waves curve by less amount. They are not complete circles. Like this. Again, the wavelength after diffraction should be equal to the wavelength before diffraction. Both should be equal. Also, in this scenario, you have to make sure कि after diffraction आपकी जो waves हैं वो कम diffract कर रही हैं because wavelength has reduced, amount of diffraction will reduce. Okay. Let's further move ahead. On figure 6.1, sketch a current voltage graph of a filament lamp and explain its shape. Okay. So let's say voltage slash V on the y-axis, current slash ampere on the x-axis. The voltage versus current graph of a filament lamp is an increasing curve. What will be the explanation? You will say as voltage across the filament lamp increases, the temperature increases. This causes the resistance to increase, hence an increasing curve. You will say as current across the filament lamp increases, the temperature increases. This causes resistance to increase, hence an increasing curve. Simple. Let's further move ahead. Figure 6.2 shows an electric circuit. Oh yeah, this is an electrical circuit. Calculate the reading on the voltmeter. Beta, how will you calculate the reading on the voltmeter? Can you see we have one battery of 12 volts? This is its positive terminal, ये negative terminal है. फिर आपके पास 3 volts की एक बैटरी है. This is the negative terminal, this is positive terminal. Can you humbly realize that the negative terminal of the 12-volt battery coincide with the negative terminal of the 3-volt battery? What will be the reading on the voltmeter? 12 minus 3, that is equals to 9 volts. Sir, आपने subtract क्यों किया? Because whenever the same terminals of a battery are connected to each other, negative negative से जब भी connected होगा तो potential difference minus हो जाता है. Okay, let's further move ahead. You have to calculate the current in the 2.4 ohm resistor. How will you calculate that? Can you realize this 2.4 ohm resistor receives 9 volts? Okay, so write it here. Voltage is equals to 9 volts. आपकी resistance क्या है बेटा? 4.2 ohms. Which formula will I apply? V is equals to IR. वोल्टेज की जगह 9 रख दिया. करंट हमने निकालना है. रेजिस्टेंस इज 2.4. करंट इज इक्वल टू 9 डिवाइडेड बाय 4.2. व्हाट डज योर करंट कम्स आउट टू बी? हाँ जी, करंट क्या आ गया? 2.1 एम्पेयर्स. राउंडेड ऑफ टिल two significant figures. You have to calculate the current in the 2.1 ohm resistor. You have to calculate the current in this resistor. What will be the current in this resistor? Now I want you to analyze something. Can you realize this is the positive terminal of the battery? This positive terminal of the battery is connected with what? Negative terminal of the diode. This lovely little diode connected with the 2.1 ohm resistor is in reverse biased condition. Whenever you are in a reverse bias condition, the current in your branch becomes 0 ampere. So you can write it here. The current here turns out to be 0 ampere. Now you have to determine the reading on the ammeter. अच्छा जी, ammeter की reading अब determine करनी है हमने. How will you do that? Here the current is what? Here the current was 2.1 ampere. यहाँ पे आपका current 0 ampere था. Can you add both of them up? Can you calculate the reading on the ammeter? Yes, 2.1 plus 0, that comes out to be 2.1 ampere is your reading on ammeter. So yeah, you can write it here. The reading on ammeter is 2.1 ampere. Now you have to calculate the electrical power transferred in the 4.2 ohm resistor. How will you calculate the electrical power? Electrical power is equals to current into voltage. करंट क्या आ रहा था? 2.1. वोल्टेज क्या था? 9. मल्टीप्लाई कर दो. 2.1 इंटू 9 क्या आ गया? 18.9 volts. If I round it off till two significant figures, 19 volts is your power. Simple as that. Nothing complicated here. Easy peasy, lemon squeezy. Let's further move ahead. Figure 7.1 shows the electric field pattern around point X. ठीक है, ये electric field pattern है around point X. On figure 7.1, draw an arrow to indicate the direction of force on a negative point charge placed on point Y. ठीक है. फर्स्ट ऑफ ऑल तो ये इलेक्ट्रिक फील्ड देख के आपको क्या लग रहा है? दीज फील्ड लाइंस आर इमर्जिंग आउट ऑफ द चार्ज. बेटा ये सारी की सारी फील्ड लाइंस क्या कर रही हैं? चार्ज से बाहर आ रही हैं. दैट मीन्स दिस इज अ पॉजिटिव चार्ज. If I place a negative charge at point Y, positive negative will attract each other. You will have an attractive force like this. Simple. State what is at point X to produce the electric field pattern shown in figure 7.1. अभी हमने यही डिस्कस किया. It is a positive point charge. Positive point charge. Perfect. Let's move on to part B. A piece of plastic is charged positively by friction. State what charge transfers occur during this process. अच्छा जी, क्या charge transfer occur कर रहा है during this process? Plastic is positively charged. What happens? Plastic loses electrons. Plastic loses the negative charge or electrons. So you can write plastic loses electrons. Simple. Let's further move ahead. Explain how the structure of an electrical conductor differs from the structure of an electrical insulator. Conductor और insulator का structure किस तरह differ करता है? Conductors have free delocalized electrons. Insulators do not have free electrons. So you can write here. Conductors have free delocalized electrons. However, insulators do not have free electrons. Insulators do not have free delocalized electrons. Simple. Nothing complicated here. Let's further move ahead. Okay. Figure 8.1 shows the single turn of a coil of a simple DC motor. Okay, so you have a DC motor. Describe the direction of turning effect as seen by an observer at point 2. So, how will we calculate the direction of turning effect? Basically, you have to calculate the direction of force. कौन सा लॉ लगाएंगे बेटा? फ्लेमिंग्स लेफ्ट हैंड रूल. कौन सा रूल लगाएंगे? फ्लेमिंग लेफ्ट हैंड रूल. Magnetic field points from north to south. The first finger will point from north to south. B. Your current is going into the page like this. Where will your force point? Your force on the left hand side will be upward like this. आपका thumb कहाँ point करेगा? Upward like this. Simple. So if your force is acting upward on the left hand side, let's do the same working for the right hand side. Current like this, like this, like this. Apply Fleming's left hand rule on the right hand side. Magnetic field like this. Current coming out. Where will your force point? आपकी force कहाँ point करेगी right side पे? Downward direction. Like this. So the force on the right side is pointing in the downward direction. The force on the left side is pointing in the upward direction. What will be the direction of the turning effect? The turning effect will happen in the clockwise direction. You will say the coil turns in a clockwise direction as there is an upward force on left side of the coil and a downward force. Oh, downward force on right side of the coil. Simple. A coil is replaced by an otherwise new coil with three turns and the same current in the coil. Oh, you have three turns. State how the turning effect compares with the turning effect in one. The turning effect increases. Turning effect क्या करती है? Increase कर जाती है. A third coil is identical to the coil in part 1 except that its resistance is 3 times greater. Resistance 3 times greater होगी तो current क्या कर जाएगा? Reduce कर जाएगा. If the current reduces, turning effect decreases. Simple as that, nothing complicated. Let's further move ahead. Figure 8.2 is a voltage time graph showing the output of a simple alternating current generator at time t is equals to t0, t1, t2 and t3. ठीक है, ये alternating current generator का voltage versus time graph है. Perfect. t0, t1, t2 and t3. Okay. So this is a graph of an AC generator. Perfect. Figure 8.3 is an end view of the plane of the coil of the generator at time t is equal to 0. Okay, at time t is equal to 0, your coil is like this. At time t is equal to 0, you have a voltage of 0. Now, always remember in an AC generator, your voltage is 0 when the coil is vertical. जब भी आपका एसी जनरेटर में कॉइल वर्टिकल होगा बेटा, आपका वोल्टेज 0 हो जाएगा. एंड योर वोल्टेज इज मैक्सिमम व्हेन द कॉइल इज हॉरिजॉन्टल. Perfect. So can you realize initially the voltage is 0, the coil is vertical. Draw an end view. Okay, so one more thing is written. The coil is rotating in the clockwise direction. Okay, so the coil is rotating like this. Draw an end view of the position of the plane of the coil at time t is equal to t1. Include the labels A and B. T1 पे क्या हो रहा है? You have maximum positive voltage. If you have maximum positive voltage, you will be in the horizontal direction. Point A like this, point B on the left side. Draw an end view of the position of the plane at time t2. Include the labels A and B. Time t2 पे देख लेते क्या हो रहा है. Time t2 पे you are completing one oscillation and your voltage again becomes zero. बेटा टाइम t2 पे आप पूरी एक ऑसिलेशन कंप्लीट कर रहे हो, आपका वोल्टेज फिर से जीरो हो रहा है. दैट मीन्स योर कॉइल विल अगेन बिकम वर्टिकल like this. This is A, this is B, and your center point like this. Perfect. Let's move on to part 3. Draw an end view of the position of the plane of the coil at time t3. Include the labels A and B. Time t3 पे क्या हो रहा है भाई? Time t3 पे you have maximum negative voltage. So you will have the coil in the horizontal position क्योंकि maximum negative है, बट ये लेबल्स फ्लिप हो जाएंगे क्योंकि नेगेटिव में वोल्टेज है. देखो आपका वोल्टेज मैक्सिमम है, इसका मतलब ये है कि आपकी कॉइल हॉरिजॉन्टल होगी. बट सिंस इट इज मैक्सिमम नेगेटिव दीज विल फ्लिप. ए लेफ्ट साइड पे आ जाएगा, बी राइट साइड पे आ जाएगा. सम वॉट लाइक दिस. ए राइट साइड पे, सॉरी, ए लेफ्ट साइड पे, बी राइट साइड पे. फ्लिप ऑफ द पार्ट वन. For each application of radioactive isotope, state and explain which type of radioactive emission is suitable and suggest an appropriate half-life for the isotope. Household smoke alarm के लिए कौन सी type of radiation suitable है? Alpha particles. Why? Because alpha particles are highly ionizing and are least penetrating. So you can write it here. Highly ionizing, ionizing, and least penetration power. Oh, least penetration power. What could be the half life of this? हमेशा जब भी हम स्मोक अलार्म यूज कर रहे होते हैं, we use a alpha particle of a very large half life. So let's say 50 years. Measuring the thickness of aluminum strips produced in a factory, the type of radioactive emission that we use is beta particles. Why? Because the beta particle absorption depends on the thickness of aluminum. अगर aluminum sheet ज़्यादा thick होगी, beta particles will get absorbed completely. If the aluminum sheet is thin, beta particles बहुत ज़्यादा pass through कर जाएंगे. So you can say beta particles absorption depends on the thickness of aluminum sheets. Half life, let's say 3 years. Okay, perfect. Lead 208 has the highest nucleon number of the stable isotopes of lead. Explain why lead 214 is radioactive. बेटा lead 214 radioactive क्यों है? Because lead 214 has too many neutrons and it decays so that the number of neutrons decreases. Lead 214 has too many neutrons, hence why it is radioactive. Lead 214 has too many neutrons, hence it is radioactive. It decays to reduce the it decays to reduce the number of neutrons. They say two types of background radiation, two different sources of background radiation. First of all, cosmic rays जरूर लिखा करो, and then you can write radon gas. Simple as that, nothing complicated here. Let's further move ahead. State what is represented in space physics by the symbol h naught, Hubble's constant. Okay, write down the equation that gives h naught in terms of speed of the in terms of the speed that a far galaxy is moving away from the earth and its distance from the earth. ठीक है, बेसिकली हमसे हबल स्पेस कांस्टेंट का फॉर्मूला पूछ रहा है in terms of speed that a far away galaxy is moving away v from the earth and its distance from the earth. Have we studied this formula? V is equals to h naught d. Hubble space constant is equals to v over d. V over d is equals to Hubble space constant. The numerical value of Hubble space constant is this. State the unit of the Hubble space constant, second minus 1. Use this value of Hubble space constant to determine the age of the universe. How can we determine the age of the universe? Age of the universe is T naught is equals to 1 over H naught, 1 divided by 2.2 into 10 raised to the power of minus 18. बताओ बेटा एज ऑफ द यूनिवर्स क्या आ जाएगी? व्हाट डज योर एज ऑफ द यूनिवर्स कम्स आउट टू बी 4.5 10 raised to the power of 17 seconds. Simple. State when cosmic background radiations were formed after the formation of the universe, yeah, immediately after the formation of the universe, and where we detect it coming from all parts of the space. So you will say CMBR was formed immediately after the Big Bang कह लो या immediately after the universe was formed. Immediately after the universe was formed. And where can we detect CMBR? CMBR कहाँ कहाँ से detect हो सकती है? CMBR can be detected from all parts of space. Simple. I hope this entire paper was clear to you. If you guys have any questions, you can ask in the comments below. And yeah, that's it for today.